The day is beautiful. Welcome to Chemistry Meal. Today on Chemistry Meal, we are going to look at calculation of oxidation number. So how do we calculate oxidation number of elements in a compound or in a radical? In this video, you are going to learn that. Subscribe to our YouTube channel at Mathematics Meal 1 and make sure you follow us on Facebook at Mathematics and Science Meal. Also, look for Engineer Iko Kichku and follow him on Facebook. Alright, so let's start the business of today. You remember that in the first part of oxidation, we looked at the meaning of oxidation and reduction. In the second part, we considered oxidation number. In the third part, we look at rules guiding oxidation oxidation number of elements. And in this part now, we are looking at calculation. So if you don't know the rules, you may have problem trying to follow us. But let's get down to business. So to calculate oxidation number of an element, we take these steps. So if you want to calculate the oxidation state of an element, oxidation number of an element in a compound or in a radical, we take these steps. So number one, take note of the compound or radical. So we are going to be using these steps and we are going to apply it to these examples. So we take note of the compound or radical. That's the first thing. You look at what they gave you, whether it's a compound or what radical. Identify whether it's a compound or a radical. Then identify the key elements. So what do we mean by the key element? We say the key element is the element we want to find its oxidation number. That particular element in the compound or in the radical that we want to find its oxidation number, that's the key word, the key element. Then number three, represent the oxidation state of the key element with a letter. Since we don't know it, we represent it, we denote it with what? A letter. And then, and use appropriate rule or rules to obtain the oxidation states of other elements in the compound or radical. So you go back to your rule because we have other elements in that particular compound or radical and we need the oxidation state, because the oxidation states of the element, other elements, will now help us in finding the oxidation state of the key element. So you go back to the rules. All these elements that are associated with the key element in the compound, how can I obtain their oxidation state following the rules guiding oxidation state? That's what that particular step is talking about. So then 4A of the step, for compounds. So how do we handle compounds? Remember, we need to take note whether what was given to you is a compound or a radical. So if you were given a compound, how do you now solve? For compounds, add all the oxidation states and equate to 0. Then solve for the word unknown. The unknown is the letter representing the oxidation state of the word of the key element. But for radicals, add all the oxidation states and equate to the charge on the radical. Then solve for the word unknown. So we are going to follow these steps on this question, and at the end of the day, I'll just give you one question as a takeaway question, just one, just as we have given here, just one, but we are going to have two. One will be a radical, and the other one will be a compound. So let's look at this. Find the oxidation state of nitrogen in NaNO2. So oxidation state of nitrogen, NaNO2. Now this is a compound. Someone will say, how do you know? There's no charge here. Compounds are formed by chemical combination of two or more elements. So this is a compound. So since there is no charge, we have two or more elements here anyway, but this is not a compound because of the word charge. So this is a compound. Okay, so we have identified this as a compound. So the next one, identify the key element. The key element is the element we want to find its oxidation number. So in this question, which element are we trying to find its oxidation number? That's nitrogen. So the key element here is nitrogen. So we have identified the nitrogen. Represent the oxidation state of nitrogen. That is the key element now. The oxidation state of the key element with a letter. So I can say, let the oxidation state of nitrogen be X. Okay? What else? and use appropriate rules to obtain the oxidation states of other elements in the compound or radical. Now, the other elements remaining, apart from the key elements, are sodium and the what? Oxygen. So, use appropriate rule to identify their oxidation state or to obtain the oxidation state. For sodium, which rule? We are going to use the rule of group. Sodium is in group what? Group 1. Yes, sodium is in group 1. You remember the oxidation, the electronic configuration of sodium is this. And now we say that for common group 1, group 2, group 3 elements, the oxidation state will also be +1, +2, +3 respectively. Now, since sodium is in group 1, the oxidation state of sodium is going to be what? +1. Okay? Then oxygen. The second rule there is that the oxidation state of oxygen is -2 in all compounds. That's why it's important that you watch the video on rules guiding oxidation state so that you can flow with us in this particular video. So for oxygen, the oxidation state of oxygen is -2 in all compounds except in peroxide. Now this compound is not a peroxide, so the oxidation state of oxygen here will be equal to -2. So having obtained the oxidation state of other elements, and we have also represented the oxidation state of the key element using a letter, then we can now proceed. For compounds, so we are dealing with compounds, so we are looking at 4A. Add all the oxidation word, all the oxidation states, and equate to 0. Then solve for the unknown. So let's add. The oxidation state of sodium is +1. That of nitrogen, the key element, we say is X. That of oxygen is -2. But we have 2 atoms of oxygen here, so we'll multiply by that, equate it to what? 0. Because rule number 7 or thereabout, we say that the sum of the oxidation state of all the elements in a compound will be equal to 0. That's why we have to equate this to 0. So we have +1 plus X. Then -2 times this will give me -4, because when plus multiply the minus, we still have minus, equals 0. So if we collect like terms, so I'm going to have X is equal to 0 plus 4, and +1 moving here become -1. So this becomes 0 plus 4 minus 1 will give me +3. So the oxidation state of nitrogen here is +3. And that's why this compound is sodium dioxo nitrate what? Nitrate 3. That's why it's sodium dioxo nitrate 3. Alright. I believe that that is very clear. So let's look at the second part of the equation. The second part of the equation, part B. We're asked to find the oxidation state of what? Of carbon in HCO3 negative here. Carbon. So this is a radical. If you follow our step, this is a radical. Now identify the key element. We are dealing with what? Carbon. So the key element is carbon. Carbon is our key element. So represent the oxidation state of the key element with what? A letter. So I can say let the oxidation state of carbon be, let me use N. Yes, you can use any letter. X has really tried, so let's try another letter. So let's now use rules to get the oxidation state of other elements. The remaining elements here are carbon, are hydrogen and what? Oxygen. Now rule number 1 in the rules guiding oxidation state of elements, we say that the oxidation state of hydrogen is +1 in all compounds except a metallic hydride. Now this is not a metallic hydride. It's only in metallic hydride that the oxidation state of hydrogen is -1. Since this is not a metallic hydride, we said in all other compounds, the oxidation state of hydrogen will be +1. So here the oxidation state of hydrogen is +1. Then the oxidation state of oxygen is -2 in all compounds except in peroxide. So this is a radical, it's not what? A peroxide. So the oxidation state of oxygen here will be -2. So now this is a radical. We move to the next step. We are not going to use this step because this step concerns only what? Only compounds. So for radicals, add all the oxidation state and equate to the charge on the what? On the radical. So for radical now, The oxidation state of hydrogen +1, that of carbon N, that of oxygen -2, because we have 3 atoms of oxygen, we multiply by 3, equals what? -1. No longer equals to 0, because that's a radical. So for radical, we add all the oxidation state and equate it to what? The charge on the radical. We have minus, so this is -1, just one negative charge. That's why it's -1. So for radical, we add all the oxidation state and equate to the charge on the radical. So +1 plus N minus 6 is equal to 0. So if we collect like terms, N will remain here, 0 plus 6, sorry, it's equal to -1, sorry. So if we collect like terms, we have -1 plus 6, then this moving will be -1. So this -1, 6 coming here is plus 6, that's mathematics now. -1 plus 6 is +5. +5 minus 1 will give us what? +4. So the oxidation state of carbon here is +4. So that is why this is hydrogen trioxo carbonate 4 radical. Carbonate 4. That 4 is because the oxidation state of carbon is +4. Wow. So far so good. I know this is quite simple and easy. So I'm going to give you just one question, 2 in 1 anyway, for you to enjoy as take-away question. So let's have our take-away question on this side of the board quickly as we conclude the class. Let's have our take-away questions. So we have take-away questions. Okay. One will be on radical, one will be on compound. So find the oxidation state of chromium in K2Cr2O7. The oxidation state of chromium here. Then the next one, find the oxidation state of phosphorus in PO43-. So find the oxidation state of chromium here, and then the oxidation state of phosphorus here. I'm going to see you in the next class. In our next class, we are going to do the correction on this question, on this take-away question, and then we'll spend time solving more problems on oxidation number. And now, after that, anyway, we are going to move on. We're going to look at the change in oxidation number in chemical reaction. Very important. We're going to look at that. Change in oxidation number in chemical reaction before we start talking about reducing agents and what? Oxidizing agents. Thank you for following us till now. Remember, subscribe to our YouTube channel and follow us on Facebook. I still remain your tutor, your brother, and also your friend. Engineer Iko is my name. Bye.